Well, hey, let's rock and roll. We got a lot of different stuff to go through, like Stephanie was saying, and I'm sure we're not going to get to all of the questions today. If you have your results in front of you, that's ideal. As we're kind of thinking through this and, to be able to kind of compare apples to apples and being able to kind of see your results in comparison to how we're going to talk through them here today. There's some different resources that are out there. This one will be recorded and will be, I'm assuming, on you guys' YouTube page and probably on the Farmer Peer Group website and stuff as well. I'm sure Stephanie will get all that posted out to all you guys. But what we want to just go through today is kind of the basics of how to read the Haney test, what the results mean, and kind of how we think about it here with Continuum Ag. For those that don't know me, I'm the founder and CEO. I'm also a 7th generation farmer from Southeast Iowa. Carolyn on here is our lead agronomist. She's finishing up the master's program at Iowa State, looks at Haney tests all day, every day this time of year. So extremely well-versed, but nobody's as well-versed in the Haney test as the guy who developed the test himself. The legend, Dr. Rick Haney, is with us. So if he can't answer the question, nobody can. So let's dig in. Okay, here's what I want to go through. A lot of different stuff, but we'll try to get as much benefit to everybody here as we can. So kind of already through some of the intro stuff, but reading your Haney test, just kind of the overview. But what I really want to get into is each parameter, because I know for me, when I first get results back like this, I'm like, okay, lots of numbers, but what do the numbers mean? Is it good? Is it bad? Am I okay? Am I doing terrible? That's what we want to be able to get into. So we have some stuff about that, and maybe a couple of suggestions on kind of how you could utilize these going forward. And we'll spend as much time as we can on Q&A. Rick, I said you're retired USDA. Rick was with USDA for a long time, but maybe intro yourself here real quick, Rick.
Yeah, I was with USDA for 19 years. I retired almost 2 years ago. I'm working part-time for Lance Gunderson at Regen Ag Lab. And so, like Carolyn, that's what I get to do most of the day is stare at numbers. So yeah. Grew up in Iowa, worked on farms most of my life. Went to graduate school late in life, got my PhD when I was 42. So, pretty different track. Nice thing is I've been on both sides of the fence.
Yeah.
From the farmer's perspective and then now the academic perspective, and trying to meld those two together is part of what the test was about.
And not to dig too deep into it, but it was during your PhD work that the Haney test started to come about.
Yeah, right. It actually started in graduate school. I just didn't know it at the time. Yeah. But yeah, it really came together about, 17 years ago or so. But yeah, it was a long journey.
So been a while. At Continuum Ag, we really took this test and ran with it. We do no-till and cover crops on our own farm. A lot of other farms in Southeast Iowa do as well. It's a core component of being able to strengthen your regen journey. But you got to think very holistic as you're looking at this as well. That's also why I like the test, being able to look at the biological components of your soil, or the basics of biology in your soil, plus look at the chemistry so you can manage fertilizer as you go. How we use it on our own farm is more like in the map that I'm showing here, utilizing zone analysis, looking at our entire operation, usually doing one Haney test per 10 acres. So zone analysis and turning those 10-acre zones into fertilizer recommendations. How we suggested that you start in this project is just start by comparing kind of two different management systems, or a native area versus in the field. It looks like a lot of you were able to follow that really well and be able to have some comparisons here. So I'm going to dig into the parameters, and as you go through it, you can kind of compare how does that, maybe really healthy soil compare to what's going on in your field, or whatever the case may be for your specific sample. So hopefully can dig into that a lot. We wanted to start here too with the ability to improve these results often ties back to these soil health principles. especially when we're talking about building up biological activity, building up the food for the microbes. It takes following these soil health principles, minimizing the disturbance, providing armor, maintain living roots, foster as much diversity as we can, integrate livestock wherever possible, but be mindful of the context for your farm. And as we're digging into these results, keep that in mind, that weather plays a factor, the soil conditions play a factor. We were pulling these in fairly early spring to get ahead of planting, and to be able to do this webinar at this time frame. Keep that in mind, that these parameters change a lot throughout the year. I'm going to show some of that. We've been doing weekly Haney testing on our own farm. Now this will be, I think, year 7 of doing really intense ongoing soil sampling. So we'll show a little bit of that to help with interpreting these results. So overall, on the right-hand side is what the report looks like. Each of you guys got these reports. I like the reports from Brookside, that they're very visually appealing, and that in general, how I read it, and then I'll turn it over to Rick real quick. But in general, I start from the upper left, and then I look at on the right-hand side. So in the upper left, IR gas analyzer. I think the newest reports might just say CO2 burst or CO2 respiration, but that parameter is a metric for biological activity. The higher the number, the higher the biological activity. We're going to dig into each of these in detail. WEOC, water extractable organic carbon, that's the food. WEON, water extractable organic nitrogen, are part of the organic nitrogen components for the microbes to use to eat the food and produce the enzymes that they need for their metabolism and their processes. We need to have these in a balance. We look at that with the carbon to nitrogen ratio, and we'll dig into what we're looking for there. It's these 4 parameters that are factored into the soil health score. Okay, so these parameters get rolled into the soil health score, and this is just an overall metric of kind of how's your biology doing, how's your soil health doing. I like to look at this. I think it's kind of interesting, but most important are the individual components that go into the score. We got to make sure that the individual components are sitting where they need to be, because they're going to influence the score, and you can get some anomalies within the score if one or two of these components is kind of out of whack. On the right-hand side is the nutrients. A lot of things very similar to what you guys are used to, what you've been looking at from your operation for a number of years. But we'll go through that. The extraction process is a little bit different, and seeing some folks maybe raising hands and stuff. Stephanie or whoever, just kind of jump in anytime. But Rick, let's talk through the extractions. I think that's step number 1, important for people to understand when they're thinking about a traditional soil analysis that's probably using a Malick or a Bray or an Olsen extraction versus what we're going to talk about today that uses water and that uses the H3A extraction. Explain the difference between the 2 methodologies.
Well, when I was researching soil testing back in graduate school, I kept running into pretty big numbers on some of these fields, and I didn't really understand why the numbers were so big. And so I kind of jumped into how these extractants were developed, and they're all several decades old, and that struck me. But what really struck me was that when we take soil and and extract it to get nutrients out of it, it heavily depends on how strong or weak that extractant is directly determines what kind of nutrients you get out. And so the thought that I've always had was, how does nature do things? Because we can do whatever we want to in a laboratory setting. We can mix up all kinds of chemicals and get out whatever numbers we want to. But if we're not mimicking as best we can what's happening in the field where you actually grow the crop, then I don't know what the numbers actually mean. So I was looking at all these really harsh extractants, and we were getting all these numbers, and they never made any sense to me. But the thing that bothered me the most is all soils, y'all see when you get your results back, you have a soil pH of a certain, 6 or 8 or 7 or 4.5 or whatever. The problem with these really strong extractants is that they pretty much ignore the native soil pH and just run over it and extract whatever they want to based on the strength of the extractant. It doesn't have anything to do with what's going on in the field and what your plant roots are doing. So the one I developed is trying to mimic what a plant root does in a given soil. So that's the biggest difference. So generally speaking, you'll see less nutrients available with the Haney test H3A extractant, but that doesn't mean that it's wrong. That means that it's actually looking at what a plant root might be seeing and not just what we got out of a laboratory.
How I think about it is the Haney test looks at my soil's current assets, what's currently available to the plant. What is the plant seeing? Okay, so you have to keep that in mind based on the time that you pull this, the soil conditions. We're looking at what is readily available right now in April, or some of these samples, early April. What's available right now? And what is that plant actually seeing? And that's what we've been monitoring this throughout the year as well, to see how does that nutrient availability change throughout the year. And like I said, I'll show some of that here in the slides. But it's looking at what is your current assets, what's currently available, versus a traditional analysis is using these more harsh chemistry extractions. They're going to strip out more of the nutrients and break more of the chemical bonds. I think of them more so as looking at my intermediate assets, what could come available throughout the growing season based on some of these biological processes, but it's not necessarily showing me what is readily available right now, like the Haney test is here. So what's readily available right now? What is the plant directly seeing, tailored to essentially the pH of your soil? Because that's what's going to drive a lot of these extractions. So what drives that process is step number one here as we dig into these results, the CO2 burst. And so essentially, my explanation of how we're looking at this is that when the results are sent to the lab, they get dried down just like any other soil analysis. And then they take some of the soil, put it in a jar, and they add some water back into the jar to mimic a rainfall. And then over a 24-hour period, they collect the amount of CO2 that is respired out of that soil, because microbes respire off CO2 and essentially breathe like we do. We respire CO2, microbes respire CO2, we breathe in oxygen, out CO2, and plants do the opposite. So the CO2 that's being respired off, we want living plants to be growing and actively able to capture that CO2 and turn that into simple sugars and into plant material and be able to actually grow and produce yield. So the higher the CO2, the more active the microbes are, the more abundant they are. A lot of times I like seeing my CO2 results. I like seeing my CO2 results over 150, even higher than that. The highest I've seen is 1,040, which, Rick, I think that's maxing out the current machine. But on the right-hand side, what I did is we looked at so I've got these for like every single one of the parameters that we're going to go through. Okay. Here's my target. I like to see that CO2 burst number at 150 or better. The highest that I've seen is over 1,000. But in the data set, which we received now about 100 samples out of this project so far, so really fun to dig into that. We're not going to show any individual results here today. I have no idea whose numbers these are. But if you look at your results, maybe some of these are you. The lowest biological activity that we found in the project is 21.6. The highest one that we found was 286, which is really, really great. The average out of the whole project was 88.9. Rick, any response and thoughts here on reading through these biological activity numbers?
Well, to me, the CO2 release is the most important test, because that's telling you a lot of things. It's telling you what the microbes in your soil think of your management, what they think of the carbon you give them. Mm-hmm. I have a slide that we won't show, but it's called "Not Organic Matter. All Organic Matters is Created Equal," because we've seen organic matter samples that both have 5% organic matter, and one could be respiration of 21 and another could be 200. Yeah. Same organic matter. So that tells you about the quality of the carbon that they see. And that's a really important number.
That's a great point, because a lot of times we see farms that might think that they have amazing, nice, heavy black soils, but their soils might be kind of dead because of some of the management practices. This is a direct measurement of how active those soils are.
I really enjoyed some of these. I don't know whose these samples are, but they had some descriptions, and a lot of these guys did field versus fence. And if you look across there, I'm looking at one right now that was a field, and the field was 26 respiration and the ditch was 166.
Wow.
So, you know, in most every one of them shows that. Here's another one that's 27 and 187. So that,
wow.
if you wonder where you're at, that's kind of telling you a little bit about what's going on.
So that's why, that's a great point. That's why I was encouraging kind of the fence row one. The fence row number is going to kind of show what is the native biological activity. Now, also keep in mind, though, that fence row might just be only brome grass or only a single species grass. Yeah, it's never disturbed. It might not get Roundup put onto it, but it's sitting there, not necessarily being actively managed. What I've seen is we can actually get better than that fence line because we can foster more diversity and stimulate more biological function in the field. But yeah, a really good way to be able to kind of compare apples to apples of what's going on in an undisturbed area versus what's going on in your fields. And it's just factor this one in. The more you can get these microbes to function, the more nutrient cycling you can get, the more function in your systems, and you can put that right back to dollars in your pocket. On my own farm, when we started, our biological activity was less than 100. Now we're consistently 300 to 350 part per million. Okay, so we started with absolutely a degraded system. We had been doing a little bit of no-till, but no cover crop, no manure. It was all synthetic. Okay, very, very traditional farm. And we've been able to see this parameter really increase. What I like about monitoring soil health with the Haney test is that we can show improved soil health in 1 year. Specifically with this parameter, we can see increases in biological activity with 1 year of adding cover crop, doing some of these practices, very, very consistently see that we can improve these metrics. And this is, I think there's a lot on this, but real quick, what this is looking at is some of my weekly Haney results. Okay. This is looking at a cover crop versus no cover crop trial. In the cover crop there, and I'm going to show a couple different slides of these weekly results. So I'll explain it here on this first one. In the cover crop data set here, it's actually an average of 3 points. There's 3 replications of cover crop, 3 replications of no cover crop. What you're seeing here is the average. How I see this is throughout the weekly time frame, usually the results track together. Mostly that's due to weather. It's due to what was going on with the soil moisture, with the temperature, things like that. That's where we see those fluctuations. But in general, seeing that the blue line is typically higher than the orange line, where we have the living cover crop or where we've had covers in the system, there is more biological activity. Now, I believe this is a corn year that we were looking at here. So my cover crop was very small, maybe 10, 12 inches tall at the most. So that's also part of why there's not really aggressive improvement where we've got the cover crop versus where we don't. And this was 2019. So we were only a couple years into utilizing cover crops. But my point here being is essentially the lowest part of the graph is in this April timeframe, and your numbers will come up in the summer as things warm up. I guess what we're looking at here is there's 2 years worth of stuff. So 2019 was the corn year. 2020 was soybeans, where I had really big aggressive cover crop. So that's why those numbers are trying to be quite a bit higher too in 2020. But point being that these numbers will change. These numbers will come up throughout the year. We wanted to get a solid baseline to start the conversations, and just important to note that these numbers will change throughout time. Rick, I think in general, this matches what you guys have been seeing, that these numbers come up, especially in the summer as the soil temperatures warm up and all that, and the plants are really actively pumping. Any other takeaways on looking at weekly data like this?
Well, I think what's important to recognize is that we're so used to looking at standard test results, which have none of this information. And so you're basically looking at a test that just is non-biological and just chemical in the standard test versus a heartbeat. I mean, now you're looking at a living dynamic system here based on and this data is showing you that Mitchell's collected.
That's a great
a
point.
very different system. And we have to think about these soil test results a little differently because now we're looking at a dynamic living system versus just a chemical system.
That's a great point. That I love that quote from you that, like, of course the numbers change like this. It's a living system. If the numbers never changed, that means it's dead. The only time it's flatlined is if it's dead. Just like in your example there of the heartbeat, your heart rate is going to be changing all the time. If you go back to the doctor time over time and your heartbeat or your heart rate never changes, probably not necessarily a good thing. might be flatlined. So interesting to see it change. It does change a lot, but factor that in to your interpretation here. And almost every time the numbers end up making a lot of sense. Okay, so to improve that biological function, we got to feed the microbes. Microbes are very simple. All they know is to eat, reproduce, try not to get eaten, and die. Okay, and these microbes in the soil, in general, eat simple sugars, sucrose, fructose, glucose, that kind of stuff. They're very simple single cell organisms. They eat simple sugars, simple compounds. Plants pump these compounds into the soil. Those root exudates of pumping those simple sugars down into the soil. And to simplify it, we're measuring that as WEOC, water extractable organic carbon. So the more we improve this number, the more food we're pumping down into the soil, the more microbes we can feed, the more function we can get out of the system. I like to see this number over 250 to 300. And there's a metric that I know you like a lot, Rick, looking at your percent microbially active carbon, where we're looking at the ratio of the CO2 burst versus WEOC. And there's some good insights to be able to pull from that to see, do your microbes like the food? Are they responding to the food? Maybe we need to change up the species or, things like that. In my entire data set, the highest water extractable carbon I've seen is 751. I was having fun preparing all these slides, looking back through my full data set of some of the highest results that I've seen. In the project here, the minimum result that we found was just over 100. Not terrible, but this average number of 202, fairly solid. It's definitely where we want to be able to get to. The maximum that we found in this data set was 414. That's definitely really, really great. And the key thing here is those living roots, more photosynthetic activity to feed the microbes. And this is kind of like what these carbon markets and stuff are about and why they want cover crop, why they want no-till and all that. With more cover, with more living roots, more days of photosynthesis, there's more days to capture CO2 and put it into the ground as water extractable carbon. And the microbes are going to eat that. They're going to cycle most of it. They're going to cycle. But as those microbes die, their carcasses essentially become that more stable humus, stable organic matter. So the more microbes we can get, the more we can build up these soils. Rick, anything I missed on that with WEOC?
No, and I think the we call that percent max score that he touched on. That is just so important because we have two fields that both have, let's say, average of 200 part per million carbon, and one's got 20 part per million respiration, and the other one has 190 part per million respiration. You're looking at two different systems and two different types of carbon there. So that's just another little indicator of what our position is. We want the soil to tell us what's going on based on these results.
So you want your water extractable carbon and your CO2 number to generally be about the same.
Well, I want to see at least half of the, a 50% MAC would be what you want to see for sure at the very bottom. In other words, half of the carbon that we extracted with water, we would like to see at least half of that released as CO2.
Yeah. So if your water extractable, if your WEOC number is 200, you want your biological activity to be at 100 or better,
Yes.
half.
Yeah. And
So
then we had a
essentially
guy
here,
call us and say one time, he said, well, my water extractable carbon's 200, my respiration is 250. And I said, well, that's good. And he said, well, that can't be. I said, well, yeah, that's a one-time extraction for water extractable carbon. And your microbes have 24 hours to chew on that CO,
Mhm,
on that carbon. And they see a lot more than we extracted at one time. So that's actually a good indication.
got it. So yeah, that's a good point. This water extractable organic carbon, that is the carbon that is readily available in the soil at the time that we pull this. It's going to change a lot throughout the year based on the above ground biomass and what is happening. But we have to continue to feed these microbes. And that's what we found on our farm. Now that we've, like I mentioned before, we've more than tripled our biological activity. We got to feed these microbes more and more and more food, because now we've got a beast underneath there. We got to feed the beast, and we have to get more aggressive with our cover crops to make sure that we don't run out of this water extractable carbon. And that's likely what's happened across the country and across the board, where we get this soil degradation. If we don't have the simple sugars for the microbes to eat, they got to turn to the next best thing, which are those more complex carbons like the organic matter, and the more long chain carbons like the humic acids, fulvic acids, those kind of things, more complex carbons. If they don't have the simple stuff available, they're going to go for the simple stuff first. But if we don't feed them, they're still going to eat, and they're going to go eat the house. What I, as a, this is the same type of data set as before. On the left hand side is through 2019, on the right hand side 2020. The blue line being with cover crop, orange line being no cover crop. Very, very consistently, a lot more water extractable carbon where we've got the cover crop versus where we don't. What I think is really interesting on this one is just how consistent the delta is between the orange line and the blue line. Like very blatantly obvious, getting a lot more water extractable carbon where we have the cover crop versus where we don't. These results were a couple of years ago when we put this graph together. And this is one of those leading indicators that we got to get the microbes their food and get them actively working. Then the communities will respond. Then we'll get more nutrient cycling. We can cut back on our synthetic inputs. Okay, so in order to eat the carbon, the microbes need nitrogen. Microbes got to produce enzymes to break down the carbon, is how I think about it. And I think of the water extractable organic nitrogen as like the tools to do it. Nitrogen is the building block of amino acids. Amino acids are the building block of enzymes. Enzymes are the building block of protein. And those enzymes are really what's needed for the plants to, or for the microbes to actually break down this carbon and eat it. And they need to have a balanced diet. A microbe is what, Rick, a C to N ratio of 8-to-1. So we've got to have enough organic nitrogen to be able to keep the soil in balance. Now, a couple different things that we're looking at with this test, and I'm going to get into the nitrogen components here later on. We're looking at overall water extractable nitrogen. And then a part of the total water extractable nitrogen is the water extractable organic nitrogen. So I was looking at a couple different things here. And going through my slides here, your target water extractable nitrogen, the result that you want to see, of course, depends. Are we growing soybeans? Are we growing corn? What time of year is it? There's not a direct target number that we necessarily want this to be at. It depends on what nitrogen you actually need available. The highest number that I've seen is 465, a lot of nitrogen sitting out there. These are part per million numbers. So take it times 2 to get your pounds per acre, because we're talking 6-inch samples. The lowest that we saw here was 8.4, especially if you're growing soybeans. Maybe that's fine for this time. Typically, I want to see it higher than that. The average of 17, very typical to what we are seeing this time of year. The highest water extractable nitrogen was 50. So that soil there has 100 pounds of nitrogen sitting available in the top 6 inches of the soil. Keep in mind that if you applied nitrogen on here, keep in mind the depth of how you pulled these samples. Maybe your nitrogen is lower down in the soil. Maybe there's more of it in the upper profile of the soil. Keep that stuff in mind here. But the key on this is nitrogen moves in the soil with water. It dissolves in water, moves into the plant via the water. And that's why Rick's test here uses water to see what nitrogen is actually available. Rick, any thoughts here?
Yeah, as Mitchell said, that it's important that we separate out. That's total water extractable nitrogen. And then so on the same sample, we run inorganic nitrogen. So the difference between total and inorganic is your organic pool. And we've never been able to account for that before this test came along.
Maybe I skipped ahead to that one.
It's really important because that's a lot of nitrogen laying on the table that you're adding fertilizer for that you don't need to.
Yep. So that was, Rick, this was one of the original reasons why you were developing the test, that to typically in soil fertility management, we only looked at the inorganic nitrogen, the nitrate and the ammonium, like doing our spring nitrate tests and stuff like that. There's a variety of acronyms, ISNT and PSNT and all kinds of different stuff. But usually we were looking only at inorganic nitrogen, nitrate and ammonium. But what is also out there is organic nitrogen, which really just means it's got a carbon molecule attached. That's the definition of a organic compound in the soil, is it has a carbon molecule attached. Carbon is the building block, the basics of life. So organic nitrogen just has a carbon attached to it. In this nitrate, that's the stuff that nitrate and ammonium is, very available for plants, of course, but also potential for water quality issues and to be lost out of the soil. Keep in mind, this nitrogen, it's always in cycle. So we can apply nitrogen as ammonium, and then it can nitrify into nitrate. It can turn into N2 gas and be lost via volatilization. Variety of things that can happen to this nitrogen here. The key thing that why I like the Haney test is we need to be looking at this organic pool and factoring it in to our nitrogen management. The average ammonium level from all the data that we pulled in this project here was 4 part per million. The average nitrate number, 1.9 part per million. The average organic nitrogen number was 11.2 part per million. There's more than double the nitrogen over in this pool than in these other two pools combined.
Well, okay. I think the point he's making there real well is that most standard tests only test for nitrate, if anything at all. So if you sent the same sample for just a standard test, it'd come back that you have 4 pounds of nitrogen.
Yep.
And the reality is, if they didn't test for ammonium, you have an additional 8 and an additional 22. So you have 30 pounds more than you thought you did. And
that's right. So really the math he's running there, guys, is take each of these times 2. These are part per million, and they're a 6-inch sample. In the top 6 inches of soil, in general, there's about 2 million pounds. So that's why you take this part per million times 2 to get your pounds per acre. So yeah, looking at these, very few pounds per acre, you'd be like, well, that stinks. I just put on a bunch of fertilizer and it's not showing up. Keep in mind that there's plenty of these samples that are pulled that don't have fertilizer on them. They're the fence lines and stuff like that. But that huge pool that we're missing, and Rick, I know you guys have been watching this and seeing on average, how much nitrogen are guys missing out on average from all the samples you were pulling?
30 to 40 pounds.
30 to 40 pounds that we're not accounting for.
Yeah, and that's just the national average. A lot of those are higher than that.
I know on my farm, we were missing out on even more than that. What I see, my organic nitrogen levels are typically 50 to 60 part per million. When I started down this path, they were more like this, 11, 12 part per million. They were low. My organic nitrogen was low because I was in a chemistry-driven system where our nitrogen program was mostly anhydrous and maybe a little bit of UAN and our MAP fertilizer and dry broadcast fertilizer. That was it. And my organic nitrogen numbers were very low. What I've seen is my organic nitrogen numbers have risen from being in that 11, 12 part per million to all the way up to 50, 60 part per million. And mostly seeing a lot of that's due to my soybeans giving me a better credit because I'm putting my soybeans into big cereal rye where they have to nodulate more. We're seeing a credit from our legumes as our leguminous cover crops that we're using. We're getting better just natural biological cycling as well by those improved biological numbers. And for our farm, we used to apply 230, 240 pounds of nitrogen every year on our corn, very typical, a 1 to 1 pounds of nitrogen per bushel. Well, now our average nitrogen that we actually have to apply is 155 pounds of nitrogen per acre, 155 units. So we've reduced from 240 units to 155 units and maintaining or even growing our yield. And it's because there's more nitrogen available in this organic nitrogen pool, and we're able to actually utilize that now to offset our fertilizer bill. And this has put huge dollars back into our pocket. And across our entire network, we're seeing very similar results to you, Rick, that, factoring in this organic nitrogen pool can really save our farmers a lot of money. So take the results that you guys have with a grain of salt. It's one kind of thing, but especially if you're seeing something interesting there, very likely worth digging deeper into, and make sure that you're not over applying, and just keep the dollars in your pocket here as well. Again, this organic nitrogen number is what I really see ramp up over time. Okay, water extractable organic carbon can ramp up very quickly. Biological activity can ramp up very quickly, but these organic nitrogen pools can really start building in just the first couple of years of building your soil health. More stable as well, which is what I like. And plants, what do plants want to do? They want to produce organic nitrogen in their bodies as well. It's called protein. So we're giving them organic nitrogen. It's already part of the way there to what the plant actually wants to produce at the end of the day. But Rick, as we're building up our soils, we have to keep it in balance, the carbon to nitrogen balance. And I know that this is where we screwed up in year number one. We didn't understand this metric. Well, we didn't understand soil health at all. We didn't understand any of this stuff when we first started using cover crops a number of years ago. But what we screwed up on our farm is that we put out way too much cereal rye, too heavy of a rate. It got too aggressive. We didn't change our fertilizer program. We didn't have the biological activity. We had too much carbon and not enough nitrogen. And our C/N ratio was way over this 20-to-1 metric. If our carbon and nitrogen ratio is over 20-to-1, we have the carbon penalty and nitrogen fixation, where in order to eat all that carbon, the microbes have to take additional nitrogen away from our crop to break down all that carbon, because they have to have a balanced food source. If we're not feeding them a balanced food source, they're going to utilize the fertilizer that was applied, or they're going to take nitrogen out of the soil. The microbes eat first. If the C/N ratio is below 20-to-1, we can have nitrogen mineralization, where those microbes are now releasing nitrogen back to our crop and cycling those nutrients back for us. Now, Rick, I know there was some things that were a little bit weird within the results that you were seeing here. Might be some calculations in the way that Brookside's running it that we're going to look into, and maybe provide some thoughts back on how some of these numbers were being around. But overall, the average of a C/N ratio of 12.3, it's kind of spot on to where I typically see it. 5.7 is probably a little low. We probably need to have a little bit more carbon into that system. We don't want to run out of carbon, which is what could happen if your C/N ratio is too low. We run out of carbon and the microbes start eating the house, eating the organic matter. But if we have a C/N ratio that's up here in the 30 range, if we've got corn in that system, that corn could definitely struggle because the nitrogen is being tied up by the microbes to eat the carbon. Rick, what do you?
Well, I think it's important to understand that this is not a soil C/N ratio. This is a water extractable organic carbon to water extractable organic nitrogen C/N ratio. So that's why he's got the food fuel balance. So that's why he's got that in there, because this is a C/N ratio of the water extractable organic fractions. And that's a real sensitive estimate of what's going on inside your soil and what the microbes are actually dealing with, and why he wants to balance that.
That's a great point. And Matt and I were talking about this on some of the conversations going on Facebook, that a lot of, as we're putting together cover crop blends, carbon to nitrogen ratio is often talked about, but that's the carbon to nitrogen ratio of the above ground biomass and of the actual plants themselves. And then there's the soil carbon to nitrogen ratio, but what we're looking at here is what the microbes and what the plants are seeing. The water extractable carbon to nitrogen ratio. This is the active pools.
What's interesting about nature is that you'll see overall seed-in ratio of soil in anywhere from 8 to 12 to 1.
Yeah.
Plants are also about 8 to 12 to 1, and microbial bodies are about 8 to 12 to 1. So it's not an accident that these things follow each other.
And essentially what we mean by these is, for like 8 to 1 means 8 parts carbon to 1 part nitrogen. And I think humans were like the same type of thing, right? Same type of ratio. So the human body, I saw something like 17 or 18% carbon. And mostly because we're mostly microbe, but that's a different story. The key point here being, as you're managing cover crop, as you are monitoring your soils, if you see things that are weird, this carbon to nitrogen ratio often helps to really tell the story. This will help to better understand as well. We factor that in as we're looking at how quickly are we going to cycle nutrients back to our system as well. Okay, last couple things. I know we're digging into this. Hopefully this has been helpful. If there's questions, start definitely putting them into the chat. Couple last parameters here, and we'll try to get some more questions in. I know this has been a lot of stuff really fast, but you can always go back through and watch and stuff as well. Okay, Rick, phosphorus. In the Haney test, we're looking at organic phosphorus and inorganic phosphorus. So that's a key thing to factor in. But overall, phosphorus, should be looked at kind of the way that you typically look at phosphorus. But the average availability here was 10 part per million. A lot of times we like to see it in 20 to 30 part per million is what we're typically seeing from our results. We've got some that you can get really high phosphorus availability, probably too high. But thoughts on this phosphorus one here. This is the early part of the year. There's going to be a lot of cycling of this phosphorus here as well, but thoughts on the results, because we had pretty big stretch here from just 1 part per million, like no available phosphorus, to 10 was the average, fairly low, to 83.
Yeah, I assume this is
highest. That's
ortho.
not crazy high.
Is this ortho or total? Do you know?
This is the total P.
Yeah.
Total
That's
available
unusual for there to be less than 1, or 1. But anyway, again, one of the things we like to look at is the total phosphorus versus the inorganic phosphorus and what's left over is the organic phosphorus. As you move down the soil health journey, you will see, just like organic nitrogen, you'll see that organic phosphorus come up. That's another indicator that you're headed in the right direction, and that the cover crops will help do that too. So it's just another sensitivity indicator on what's actually going on here. And the way we do this, if you need X amount of pounds of P2O5 fertilizer, and this shows that you have, let's say, you need 80 and you've got 30, then add 50. I mean, this is designed to do it that way.
Mm-hmm. Yeah, that's what I like. So in the reports that you guys have, there are some fertilizer recommendations on there. It's just for 200 bushel corn. I didn't change any of the recommendations. It's just what comes directly from the lab. But in the upper right corner of the report, there are some fertilizer availability numbers there. And that is taking your phosphorus availability, converting it to P2O5, which is how we typically look at phosphorus availability from traditional analysis. So it's looking at your actual pounds of P2O5 available per acre. In the lower right-hand corner, there are some recommendations looking at the availability, or looking at potential to apply these nutrients. But you were just hitting on something good there, Rick, that the overall approach with managing fertilizer with the Haney test, we're still looking at the same yield goals, the same nutrient need to produce the yield goal. We're just getting to, well, what's available in a little bit different angle. We're looking at what's available in the soil. Here's my total need. Here's what's available. Now I can fill in the gap with the fertilizer that I actually need to support the yield goal that I have. Slightly different approach than how things have been looked at in the past. Okay, we'll keep rolling and not try to get too carried away here. Organic matter. This organic matter analysis is the same that I'm sure plenty of you have done for multiple decades on your farm. And wanted to look at this one real quick, that, you know, any of these carbon programs and stuff like that, that organic matter on average is 58% stable soil organic carbon, or stable, more stable-ish, more long-term carbon, longer cycle. And of course, the higher we can get our organic matter, the more we can improve water holding capacity. It's the house for the microbes, more nutrient holding capacity, all that kind of stuff. The lowest result that we had in the project here was 1.6. The average is 4, which is pretty good. And we had one though that was at 9, and we were digging into this one because we know who it is. And this one was a soil that has been it's been hitting all the soil health principles for the last multiple years. No disturbance, continuous living root, some diversity into the system, and really, really paying off. That 9 organic matter is crazy good. So just one of those things, of course, to continue to watch. But Rick, you do talk a lot, and you had mentioned before, not all organic matter is created equal. We have to factor in that this is the organic matter, the home for the microbes, but the water extractable organic carbon, that's the food. So you got to get the food to improve biological activity, and that's going to lead to improved organic matter over time. But some farms might have good organic matter, but poor water extractable carbon and poor biological activity. We've got to build all these things up together.
Yeah, that's exactly right, because it all works together. And we've seen so many examples, thousands of examples of, organic matters being the same in a couple of soils, but wildly different soil health scores, because the type of carbon or the way it's been managed, it just has a huge impact. And the whole idea here is to manage these things as efficiently as possible, so that you're as efficient with your fertilizers as you can be, that you're feeding your biology, and then everything kind of starts working together.
Right. Keeping all of these things kind of in balance. One of those balances is, of course, pH. Like everyone's seen pH results before. This is just looking at the chemistry balances within the soil. I like to see my soil pHs in that 6.7 to 6.9 type of range. The average here was this 6.56. This really low pH. We're seeing, very acidic soils there, that 5.2 pH. I bring this one up because as we're thinking about building our soil health, if the soil is too acidic, we might struggle building up our biological function if we're trying to grow microbes in an acidic system. Just like if it's too alkaline, if we have too high of a pH. So we got to balance these things out, and it's just part of overall building soil health. To my definition of soil health is its balance in the chemical, physical, and biological components of the soil. We've been talking about biological balances. This is one of those chemistry balances that's important to look at here as well. But Rick, thoughts on that? Jonathan, thanks. I got your email marked down for us.
Yeah, I think pH is an important aspect. One of the things that I look at on these results is the calcium iron aluminum ratio, which tells us something about why the pH is what it is. And, that's kind of just an interesting another take on the way we look at this, since H3 extract is more of a natural extractant. So, for example, like Mitch just pointed out, that one pH is 5.2. Well, I just looked up here. I think this is it. And his calcium iron aluminum ratio is 1.8, which isn't terrible. If it was less than 1, that means you have more iron, aluminum than calcium. Then you're probably looking at liming. Then
you're having some issues. So it's a low pH, but that's one part of the story. And there's some other details too. Okay, so to wrap up here there's opportunity for more, Q&A sessions or whatever. We'll dig into some of that. But what I think, some of my ideas and stuff here for how you can utilize this stuff going forward. We went through things really fast today. I'm sure there's a lot of digging into the results that can be done. Maybe a good opportunity for the farmer peer group meetings. Go and take your results. If you're willing to, share them with your peer group members. All this data that we collect here, like farmers, you own the data. Nature Conservancy paid for it, but you own it, and they haven't seen any of the data. They don't get any of the data. They don't need any of the data. This was a experiment and a project for you guys to be able to get some numbers, to be able to have these conversations, be able to see kind of what's going on within your soils. I've really liked using the Haney test as throughout our soil health journey. It's a tool. It gives us some great numbers, some really in-depth stuff. And I like that we can manage our fertilizer with it. We're going to put on fertilizer anyway. Let's get the best results that we can and manage that fertilizer appropriately. So, compare some of those, compare and contrast your two samples next to each other, maybe print them out and look at them side by side, or look at some of the rest of your peers. The slides here will be, available. The recording is available. So you can kind of compare your results versus the rest of the group. If you want to go further, you can utilize these recommendations, for influencing your in-season management, maybe just tweaking and adjusting a little bit. But if you want to take this and really get aggressive with it, that's where I recommend doing more of the sampling across the whole field with zone analysis, or getting more aggressive with some of these results. There are some of the sampling protocols just to be able to get more of a complete picture of your operation. So, and you can build up your soils and get all that nice fungal activity like we got there, Rick, right? It's a guarantee. Everyone's soils are going to look like that in no time. Last kind of stuff on my side, wanted to throw out, we're hosting a conference in Iowa on June 5th. I've got, like I said, a variety of things on our website, on our YouTube page, just trying to be a resource as much as we can. Appreciate everybody that participated in this project. I think it's gone fairly smooth. I'm sure there was some hiccups along the way, but thanks everyone for being part of it, and happy to take some more questions and support everybody as much as we can.
Yeah, so thank you so much, Mitchell and Rick and Carolyn. I don't know if you have time now to stay on. If people could raise their hand if you want to raise your hand or put it in the question and answer. And I know Matt already had a question. So if you're on here, you want to, you could raise your hand, and we'll let you turn on your microphone. Also, if you don't have time to stay on and you have questions, we're going to have some follow-up meetings. Please email me, please email Matt or Mitchell or all of us. What we really want is for you to be able to understand your results, and 1 hour of talking about it probably isn't going to get you there. So just know that it's our goal for you to have a good understanding of this test, and also for you to share that with your peer groups or the person who's currently advising you on your nutrients, so we could all have a better understanding on how this test could help us move forward with our soil health. That's
totally right. Yeah, we want your local service providers, your local advisors to be involved in this stuff here as well. Like, we want to bring them to the table. We want to make sure that they understand. We need more folks understanding what soil health is and understand how to read tests like this, understanding so we're all talking the same talk and that we're all helping to move in the right direction here. We got a long way to go with that, but yeah, I think that's spot on though. Matt, you get question number 1 though, it sounds like.
Yeah, hello everyone. Thanks, Mitchell and Rick and Carolyn and Stephanie. On my test, it's a 30-acre field, and I took 10 different samples throughout the field. So, I mean, I went like 3-acre grid. So I'm hoping I got a pretty good balance.
Yeah.
My C to N ratio was between 21 and 27. So last year's crop was wheat. The current cover crop is annual ryegrass. So if I'm going to apply 5 gallons of in-furrow and 17 gallons of 2x2 fertilizer of 28 and 10-34-0, is that enough? Is there enough N there to get my corn crop off to a healthy start?
Rick, you want to go first or me?
Yeah, you go. Yeah.
What I like doing here, Matt, I mean, the result itself, again, with these seed-in ratios, Rick and I were seeing maybe a little bit of funkiness. So that's probably step number one, is let's dig into it and see if there's a little bit of funkiness going on. But those results aren't crazy bad. They are a little bit concerning, but with your 5 gallons going in furrow and with your 2x2, I think you're going to be okay. Another tip that we use on our own farm is when we burn down the cover crop, to use a little bit of 32% with the herbicide at the burn down. Okay, so and what I do and what I would do in this system is I'd go and plant it green still. Everything we do, we plant green. So I'd plant the corn directly into this stuff, and then like 2 days later, go out there and get it terminated and add 3-4 gallons of UAN with the burn down herbicide. What I think is happening there is that we're getting more of that nitrogen directly on the actual grass and the residue itself to provide a little bit more of that nitrogen right there for those microbes to get that stuff broken down. Going forward, this is where there's opportunity for more legumes in that system, hairy vetch, things like that. Build up these soil parameters over time. Over time, your system will be cycling even more and be able to handle it. But essentially, you've got wheat that has a carbon to nitrogen ratio probably of 40 or 50 to 1. Then you've got this annual rye that has an above ground, or an actual crop carbon to nitrogen ratio, again, in that probably 40 to 50 to 1. So you got a lot of carbon and grass. Now you're going to plant a grass that's corn, and they're all after the same nutrients. So we could definitely balance it out yet. I definitely like the little bit of UAN with the burn down, though, would be the quick fix.
I have heard that like adding the UAN in the burn down can cause a problem with the translocation of the herbicide through the plant. Is that correct or no?
Yeah, that's why I like doing the light rate.
Okay.
Light rate on the UAN. Don't get it too hot and just completely fry it so it doesn't translocate that Roundup or whatever you're going to use. But yeah, there's a balance to it for sure.
Okay. We had peas and clover and some vetch in the mix last fall, but thistles just got really bad. So we just did a fall burn down of like 2,4-D just to kind of get that under control. Makes sense. That's why it's just a grass.
Makes sense. And I think that's actually a good note to bring up too. As you're going through this journey, you're going to have bumps in the road, and it's much smarter to take care of the thistle problem now, so it's not a thistle catastrophe in the years to come. So
that was the plan.
Yeah, that's good. Rick, other thoughts on that, or do you think I'm thinking about it the right way? That like with that above ground biomass, getting a little bit of extra nitrogen right there on the plant to help the microbes break that down. Like, does that make sense?
Oh yeah, back in the olden days, we had sticks and rocks for farm equipment. We used to, some of those farmers in western Oklahoma used to add a little nitrogen after harvest because they had no organic matter and the stock was just stay there because everybody wanted a clean field back then in the 70s and 80s. But yeah, it works. I mean, again, nature knows what it's doing, and if we don't have the right balance of seed-in ratio, then things don't click along.
Yeah, makes sense.
Great.
Great,
Are there
thank you.
any other questions from the participants? There should be a place on your screen to raise your hand. If you do have a question, you could just hit that button. Oh, Jeff has a question. Let's let Jeff talk. Jeff, you just have to take yourself off mute and you can ask your question.
Got me now?
Yep, great.
There you go, Jeff.
Okay. I'm totally confused, but you were I was winning all the low numbers here today on my best. This is my best farm I farm. It's vegetable ground. Okay. It's been no-till cover crops for, I can't remember when we did. And I got the lowest scores. And then we sent in like 6 samples here. My worst ground, I don't even want to farm it anymore, but it's got some of the highest scores. So,
wow.
So yeah, I'm a little baffled here. So But yeah, I don't know if you got the Kelly farm there of mine.
Yeah, let me see if I can find what you're looking at.
Well,
here.
when you say worst score, what does that mean?
Well, it's low. I got what the pH with 5.8. We did spread lime this last fall on that, so it's probably not into the soil solution yet, probably. But my CO2 burst is 24 on the one sample, 22 on the other one.
What was the water extractable carbon?
177 and 168.
So the food's there, the microbes just hadn't got going yet, right?
Yeah, microbes just hadn't fully gone. So keep in mind, Jeff, I mean, these were sampled, middle of April.
Correct.
So they'll get up and get going. But I mean, yeah, Rick, the results there are definitely showing a little bit low in that biological activity. And the food, nothing crazy, but what's the food look like at this time that you pulled it, Jeff? Like, what was there? Was that living cover really actively going out there, or what?
Not yet. We're cold up. We're cold up here. The rye is, well, right now I have soybeans planted in this field, but I just wanted to sample this field just because, like I say, it's some of my best ground. The neighbors plant tomatoes right beside me, so we know it's top-notch soil. And I have soybeans planted, but the rye is still growing out there yet.
Yeah.
But it'll go to corn next year. So just trying to get a feel what is going on here.
So
one of the things that we've seen at Region Ag Labs, because the data analysis I do there. So when we come out of winter, right, if everything's cold and temperature has a huge impact on microbial activity. Huge.
Right.
So as it warms up, you expect those numbers to come up. You've got the carbon there. So I wouldn't throw it out now saying, oh, this is all terrible. It's like, no, system's not running yet.
Yeah. This is more sand, versus the other samples we send in are very heavy clay, Paulding clays. So
these organic matter, like your pHs are, I guess those pHs are low, but your buffer pHs are showing okay. But the organic matters are 2% or just shy of 2%. So a little bit lighter soils. But one of the things I'm looking at here is the phosphorus and stuff. What about any thoughts and availability for manure, compost, that kind of stuff?
This has had hog manure on it. It's had cattle manure spread on it. We just can't build this farm up, but it's 300 bushel corn ground too. I don't, maybe we're not feeding it enough, so I guess we're not feeding it enough, in my opinion.
Well, and I suppose with it being sandy soils in this time, that it was, it wasn't woke up yet, it wasn't really going yet. Some of that manure that you're putting on, it's lower than the 6-inch sample too. Where you're knifing in that hog manure, it's down lower than what we were sampling, but still, like, it should pick up some more. Like, I mean, I'm with you. Like, I definitely look at these results like, okay, this is like, we need to get after this and figure out what's
we've got grid samples on this farm, 2.5 acre grids. Like I said, when we did these Haney tests, we did a normal test too, sent them in. But this is a project field. But like I said, it's been no-till and cover crops for as long as I can remember. So I can't remember very far though either.
But the food is getting there. You're getting the food built up at the time of year. Like, those microbes are probably there more throughout the rest of the year, but because of those lighter soils, it just doesn't have the ability to really hold and build. It's going to take more time to get this stuff built up. That's part of the journey here with these lighter soils versus on a heavier field that we can get some of these things built up. There just might be some other balances that are a little thrown out of whack on some of those heavier fields that are hindering yield. And but also keeping in mind that number one thing that's going to influence yield most of the time is water. And like, is this irrigated?
No.
Okay. So
usually doesn't have, I mean, this, like I said, it's a tremendous field. So it's got moisture down there. The roots get to it and
got it.
But we'll keep studying this. So.
Interesting. We'll have to definitely happen to dig in some more, Jeff, and or compare what you were looking at from your traditional analysis and stuff as well.
Yeah, so we probably have time for one more question. And then if we didn't get to your questions, and I'm sure a lot of you have them, please type up your questions, email them to Matt and I. We'll share them with Mitchell and Rick. Also, we've put Matt's phone number on some past emails. We're available to talk to you.
Mhm.
What we would like to do. There was a question and now the hand went down. Let's see.
Well, my question is next time you put on one of these on, can you at least keep Carolyn from talking so much?
Yeah.
Actually, we had planned for Caroline to do a really nice example.
Carolyn's doing the whole next one.
I can't get a word in around Mitch. This is a very normal day in my life.
Carolyn, what did we miss?
I would have said all the same stuff though. You guys did great.
Okay, well, thanks for everyone who joined us. Thanks to our panelists. Thanks to the participants, and we'll all be talking to you again soon.
Yeah, Brandon and Jonathan, I got you guys' emails down. I'll get you those results sent. And yeah, if anybody else is missing their stuff, definitely let any of us know, and can get you that stuff. And yeah. So
yeah, another thing that I think I already said this, but I'm just going to repeat it. Write down your questions, write down the things that you were hoping to get out of this webinar, but that you didn't, because we want to address those.
Yeah.
So if there was something that wasn't covered that you'd like to understand, please let us know.
Yeah. And we only looked at a set of the parameters here too. You know, there's even more stuff to the test than what we had the time to go over as well. There's a lot there and a lot to understand. And it's okay to feel overwhelmed with this stuff. Like I've been deep into this for almost 10 years and still a long way to go to learn and to figure it all out. So to not be afraid to ask questions and to figure it out and learn.
Good philosophy.
Yeah.
So thanks everyone.
Thanks everyone.
Let's all have a fabulous day.
Have a good
Bye.
one, everyone. See ya.